Okay, this is question 9 on the sample final. Here we have an equation, cosine of 2x is equal to negative square root of 3 over 2. And we're supposed to solve that on the interval from 0 to 2 pi. Notice that there'll be tons of angles that will give you negative 3 pi over 2 because the cosine function is periodic and goes on forever and ever. So there'll be an infinite number of values that will give you a solution to this, but we just want the solutions on the interval from 0 to 2 pi. Okay, so this is my way of doing it. Actually, I'm going to show you a couple ways to get the first part. So we're going to solve this on the interval from 0 to 2 pi. And I'm going to figure out what 2x is using the unit circle. I recognize that this is one of those special values from the unit circle. It's at 30 degrees here, or pi over 6. The cosine, or the x value, is square root of 3 over 2. Okay, so that just lets me know that 2x is got some relationship to pi over 6. I'll show you what that relationship is in a second. Okay. Now, using the calculator, I can invert, right, square root of 3 over 2 with the arc cosine function, and I get this decimal approximation here. Now, of course, it doesn't want a decimal approximation; it wants exact solutions. But I know that the exact solutions will be some ratio of pi. So if I divide pi out, I get this other decimal, which is going to turn into a fraction. And a lot of calculators have either a math frac or an F to D button on it that will convert this decimal to its fraction. So the inverse of square root of 3 over 2 is really 1/6 pi. And you'll notice I did the positive, not the negative over here. I'm going to adjust for that right now. Okay. So, so cosine of 2x equals positive square root of 3 over 2 when 2x is equal to pi over 6. But in our problem, the cosine is negative. All that means is that that the angle is going to be pi over 6 in the second quadrant and the third quadrant, because that's where cosine, or the x values in these triangles, are negative. Okay. Hopefully that makes sense. So it's really going to be this angle right here, and then this angle where we're going to have solutions for the negative square root of 3 over 2. Okay, now figuring out what this angle is, I just take, this is pi, right? 180 degrees is pi, so I'm just taking pi and I'm subtracting pi over 6. And I get 5 pi over 6. And I can do the other thing to find the angle in the third quadrant. Just add pi over 6 to pi. Pi plus pi over 6 gives you 7 pi over 6. Okay. So what this means is our solutions to this equation are going to be 2x is equal to 5 pi over 6. And then every 360 degrees, or every 2 pi radians, right, we're going to have another solution. So we write plus 2 pi n, which just means if I go another full circle, I'll have another solution. And you might be like, well, we only want to find solutions in 0 to 2 pi, from 0 to 2 pi, so why would we do that? But you'll see why in a second, because this is going to get shortened up by whatever is a factor over here. Okay, and then we have the same thing for the second angle, 7 pi over 6. We have solutions where 2x is equal to 7 pi over 6 plus any full circle added to that angle. Okay. Now what we do is just divide both sides by 2, and you see I'm dividing both 5 pi over 6 and the 2 pi n by 2. So all my solutions are going to be over here 5 pi divided by 12 plus pi times n, and then 7 pi over 12 plus pi over n. Okay. And then from there, we just find the iterations, because we're no longer rotating by more than a circle, just by a half circle. These these values will have a second solution inside the just one complete revolution, right? So of course, if I let n be 0, I have the regular solution, just 5 pi divided by 12. But if I let n be 1, right, and I'm adding pi to 5 pi over 12, I get another solution at 7 pi over 12, sorry, 17 pi over 12, okay, which isn't 2 pi, right? That's still, that would be 20. If it was more than 24 pi over 12, then that's when we're talking a solution that we're not paying attention to anymore. Okay, same thing with this set of solutions. So if n is equal to 0, then I have one solution at 7 pi over 12. But if I rotate a half circle, right, if I add pi to it, then I've got 19 pi over 12. Okay, so I've really got 4 solutions here: 5 pi over 12, 7 pi over 12, 17 pi over 12, and 19 pi over 12. Okay. The next solution will probably be another 12 pi. So that would be what it would be when this is 2, and you would get 29 pi over 12, which is more than 2 pi. So that's not a solution that we're looking for. So just these 4 are within the one complete circle. And so those are the solutions that we have here. So I hope that makes sense a little bit. It's a little complicated because there's so many solutions to trigonometric functions. And you have to really pay attention to where they want those solutions. Sometimes they'll say from pi to 2 pi, right? Only the second half of the circle. Okay, I hope that helps a little bit.